All right, this is lesson 1.1 for our Pre-Calc 12 class. Unit 1 is called Functions and Transformations. Lesson 1 is called What the Function. In this lesson, we're going to learn what is a function, talk about where we've heard that word before, and what it means in math. And we're going to talk about how to know if a particular relationship is a function. So, you may have heard the word function before. Maybe like you're going to a school function or a social function, party or something. A bridge, you could say, has a function. We've heard the word function there. The function of a bridge is to get you from one landmass to another. Or we could talk about a car has a function. Its function is to get you from point A to point B. Or there's many parts and systems that make up a car, and they each have a particular function that makes the whole car work the way it does, and the way it's supposed to. And the purpose of the car is to get you across the bridge to that function, right? Anyways, in math, we're going to talk about functions as such. It refers to a particular relationship that assigns each element in some input set, we're going to call set X, to exactly one element in an output set, we're going to call set Y. So in this case, set X is all 1, 2, 3, 4. There's the bell, don't be late. Set Y is the output set. The elements in there are A, B, C, and D. So X, we're going to call, is also called the domain, and Y is going to be called the range. So 1, 2, 3, 4 are all elements in the domain, and A, B, C, D are all elements in the range in this particular example. And so in this case, like just for example, there's nothing magical about these arrows, but like if we say 1 maps to A, 2 maps to C, 3 maps to D, and 4 maps to B, for example, that's just one mapping for a function. We'll unpack that more as we go. All right, so given a definition for a function, we're going to say f of x is equal to 5x plus 1. For example, f is the name of this function, and x is the input. We're going to multiply it by 5 and add 1. Whatever that numerical answer is will be the output, or our y value. So let's see here. We can assign, let's say 5. Any real number could be an input. So let's say 5, or let's start with negative 1. Let's go on our list. Negative 1, if I put that in there, I multiply it by 5, and I add 1, and I get the output of negative 4. So on our mapping, negative 1 will map to negative 4. If I plug in 2, f of 2 would be 5 times 2 plus 1, so that would be 11. 2 maps to 11, so I'm going to draw an arrow from 2 to 11. F of 5 would be 5 times 5 plus 1, or 26. So I'm going to have an arrow from 5 to 26. And f of 8 would be 41. 5 times 8 plus 1. So 8 maps to 41. There we go. So here's our mapping that matches this function, f of x. All right, so some examples for your homework. Here's how you can tell if the following mapping is a function or not. One key word to know is that each input is uniquely mapped to only one output. So in this first example, example A, there's an element 2 in our input set that gets mapped to not only B, but also C. For that reason, this is not a function, because each input doesn't go to exactly one output. That means it's not well defined, so not a function. In example B, each input has only one arrow coming out of it, which means that each input is mapped to exactly one output, so that is a well-defined function. So this is a function. 2 and 3 both map to the same output, and that's okay. That's still a function. It's just the other way around that doesn't work. Example C is a function because each input maps to exactly one output. Okay, so the same question, but with a different representation. Instead of giving a mapping like before, we're giving a set of points. So example A is 4 points. The x values are all the inputs. So we could take the 4, the 5, the 2, and the 0, and make our input set out of those. The y values would be the outputs, or the range, 3, 8, -1, and 2, so we can make a list over there of those output elements. And then 4 would map to 3, and 5 would map to 8, 2 would map to -1, and 0 would map to 2. So we just draw those arrows straight across. And as you can see, this is a function. Example B is not a function because I see 2 show up as an input twice, but in the first time 2 maps to 3. However, in the second time 2 maps to -1. So we have, if we drew the diagram, 2 would be in the input, but it would have 2 arrows coming out of it. 1 arrow going to 3 and 1 arrow going to -1. So for that reason, not a function. Example C is a function, and I can see really easily the x values is -1, 0, 1, and 2. There are no repeats. So if I drew that diagram, each x value, each element in the input would have 1 arrow coming out of it. So it is a function. All right, third type of example, we're looking at graphs. So again, if I want to draw out, I didn't draw, I probably should have, the mapping diagram for this. If I pick any x value, I'm going to get only one y value. So like for -6, if I find -6, I have to go down to hit our curve. Once I hit our curve, I go right, and it looks like it's about -3.5. -6, there's no other output I can get. I have to go down to this point and then go right from here. In fact, for any x value, there's only one way. If you go vertically up or down, I'm only ever going to hit the curve once. However, in this example is not a function. If I pick, for example, 8, I could go up to hit the curve and find an output, or I could go down and hit the curve and find an output. So if I do the mapping for this one, 8 would be an input element, but it would have an arrow going to 5, and it would have an arrow going to -5. So 2 arrows coming out of the same input, not a function. Easier way to remember this one. This seems to be the trickiest for most people. However, it has the easiest trick. So, and that trick is if you can draw a vertical line and hit the curve more than once with that one vertical line, then it's not a function. That's it. It's got a unique name. It's called the vertical line test. That was sarcasm, I'm sorry. Vertical line test. If you could draw a vertical line and hit the curve more than once, it's not a function. That's all it is. In this case, there are multiple vertical lines that I could draw to hit the curve more than once. For example, at x, 8 is the x value. I hit the curve twice. I could do the same thing at 7 or at -2 or at -8.
Can all grade 12 students that are doing course changes with the last names I through N please make their way to the Student Learning Center? That's all grade 12 students that are doing course changes with last names I through N. Thank you.
Intercom. This one is a function. I can draw the vertical line test. Any vertical line would only hit this curve exactly once. Or I could say that any x value input maps to only one y value output. All right, there's a summary of those 3 graphical examples. Again, vertical line test is a really easy way to determine function or not. Key takeaways, we can identify a function from different representations, a diagram mapping a set of points and through a graph. We understand the set of inputs to be the domain and the set of outputs to be the range, or x's and y's. And we learned that the vertical line test is very helpful for seeing if a graphical representation is a function or not. And that's it.